Okay, so now we're on 7.1, and we're talking about the inverse, sine, cosine, and tangent functions. So remember, the regular sine function was the one that went through the origin, like that, and the regular cosine function looked like that. And so now what we're doing is we're doing the inverse. And so in this case, what we're going to use is the bottom row. So just comparing them at first, the sine graph, looked like this, where your domain was all reals, which was negative infinity to infinity, and your range went from -1 to 1. So now we're going to do the inverse sine. So you press trig, and then underneath those, you have all these things with the -1. Those are the inverses. So the -1 part, and then again we're going to put x. Now it's going to be much shorter, and we're going to go into a lot of detail on it. But basically it's going to have to pass not only the vertical line test, but also the horizontal. And so it's shorter. It just is this little part right there to there. Okay, so that's your inverse. And then there's a shorter one for the cosine also. So the regular cosine graph, trig cosine x. The regular cosine looks like that, and the inverse cosine of x looks like that. So it's slanting down that way. And then there's one other one, the tangent graph looks like that, with all the asymptotes, and the inverse tan graph looks like that. So it's tilted that way instead of like up. Okay, so now let's fill in the blanks, but those are the graphs and things we're going to be talking about. So recall that regarding inverse functions, a function's 1-to-1 if it has an inverse function. Remember we talked about this on inverses when we talked about log graphs and exponential. And it's also going to be trig and inverse trig. Inverse trig. So like the sine -1, cosine -1, etc. Okay, so if a function is not 1-to-1, it may be possible to restrict its domain in some suitable manner so that the restricted domain is 1-to-1. For example, x squared is not 1-to-1, but if we restrict it, so there's your x squared like this. If we restrict it to just the right side, then it would pass the horizontal line test. In this section, we're dealing with inverses of trig functions. Applications and word problems include hours of daylight in a given city, being first to see the rising sun, movie theater screens, area under a curve, and the shortest distance between two cities. Okay, so your objectives are to be able to use and to be able to find the exact or the approximate value. It's going to be exact if we use our unit circle. Like for example, we know sine of 30 degrees is 1/2. Okay, so before we have like sine 30 is 1/2, Now we're going to do the opposite, like sine -1 of 1/2, and it's going to be 30. So let me show you how that works. On your calculator, well, I guess I already have it typed out. When I did sine of 30 degrees, I got 1/2. If you do inverse sine of 1/2, and if you were in radian mode, you got pi6. And then if you do the inverse of 1/2, when you're in degree mode, you get 30. So just on your regular scratch pad, you can get the individual values. Remember, sine relates to y, cosine relates to x. So the next objective is to be able to use your properties to find exact values of certain composite functions. What we mean by that is sometimes you may have things like sine of sine -1 of x, or sine -1 of sine of x, and you're going to have different answers for them. And you could also do this with cosine. You could have cosine on the inside or outside, and then the inverse at the other place. So it's going to be a certain domain that we're going to restrict it to be valid. You have to work inside out. Okay, so the third thing is be able to find the inverse function and then to solve equations. Okay, so for your notes, to start with, to see if a relation is a function, see if it passes the vertical line test. So that's if it's a function. And to see if it's one-to-one or invertible, then you have to use the horizontal line test. Okay. And number 3, when finding the exact value, that means it should be in terms of pi, which means it's on the unit circle, or it could be a square root in some cases. So that's what we mean by the exact value. That means don't use your calculator and round. Okay, number 4, when finding an approximate value, express the answer in radians. So use radian mode, not degree mode, to the specified number of places. Sometimes it may be 2 decimal places, sometimes 3. It just depends on the problem. When finding the inverse, you have to switch x and y and solve for y. Remember that your interval notation may include brackets, 1 bracket, 1 parentheses, in either situation like that, or just with parentheses, depending on if it includes the endpoints. For example, if the domain of f is -1 less than or equal to x less than or equal to 1, then we would do that as bracket -1, 1. And the domain the domain of f matches the range of f -1, and so that would also be from -1 to 1. But if you're doing inequalities, you'd need a y there instead of an x. So basically, the way it works is for sine, your domain is -infinity to infinity, and your range is -1 to 1, which means for sine -1, your domain is going to be -1 to 1. And then your range, I believe, would be -infinity to infinity, because I think they just switch. The range of f should look similar to the domain of f -1 if you're using interval notation instead of your inequalities with x's and y's. Okay, so for the inverse sine function, you could look at a book on page 442, which shows you this table. Like for negative pi halves, it's -1 and so forth. Or you could just say, okay, so negative pi halves meant we go backwards pi halves, so it's the same as 3 pi halves. And since we're doing sine, we're using the y value, so we get -1. And so that's how come that's -1. And so for negative pi thirds, that means you're going backwards pi thirds. And so we get -√3/2 for our y value. And so you can either use your table if you check out a book, or you can just use your unit circle. Okay, so what y equals sine -1 means is that x equal sine y. So basically the way it works is this. I'm going to write it out. You have y equals sine -1x. How we get rid of that inverse is do sine to both sides. So it's going to look like sine y equals sine of sine -1 of x. And then the sine and sine -1 cancel, so you get sine y equal x. And that's the same as what we have here, x equals sine y. So basically we switch x and y and replace the inverse with the regular. Any questions about that part? And then the next part is we have to go from -1 to 1 for x, but then for the sine -1 to be defined, we have to go from negative pi halves to pi halves. Because if you think about the sine function, which is like this, and we have to think about where it would be passing the horizontal line test, we want to center it from like here to here, which is your negative pi halves to pi halves. So we're only interested in this section of it. So instead of actually being from -infinity to infinity, we have to restrict, and so it's going to be from negative pi halves to pi halves. So you have to make sure it's valid where it passes the horizontal line test. So within just this part, it's good. Okay, there's no places where a horizontal line would cross it. So we need to restrict it from negative pi halves to pi halves. Okay, so again, switch x and y and change from the inverse function to a regular function. Okay, now if you have your f -1 on the outside and your f on the inside, that example with sine would look like sine -1 of sine x. And that's equal to x, and I gave you the interval. It's going to be from negative pi halves to pi halves. So notice when f -1's on the outside, that it's going to be, from negative pi halves to pi halves. Now, if you do the opposite and you have the inverse on the inside and the function on the outside, that would look like sine of sine -1 of x. Then you're going to have a different domain, basically. This compared to this. So then it's going to go from -1 to 1. So you'll probably need to keep up with these notes, or just remember If it's sine negative 1 on the inside, then it's going to go from negative 1 to 1. So I could just summarize that real quick. When sine negative 1 is on the inside, it's negative 1 to 1. Since it's like the range of sine. If you want to write that, you can. When sine negative 1 is on the inside, it's negative 1 to 1, since it's the range of sine. Okay, so now we're going to talk about the inverse cosine function. And again, you could use a table or use your unit circle, but again, cosine relates to x. I guess let me jot that down. Cosine relates to x, sine relates to y. Okay, so when we do y equal cosine negative 1, that means the same thing as x equal cosine of y. So just like we did before, switch them, switch the inverse function to the regular function, and change x to y. So here, when you're doing cosine negative 1 of cosine, this time the interval goes from 0 to pi. 0 less than or equal to x, less than or equal to pi. And so it's the interval 0 pi. But when you do your cosine on the outside, this time it's going to go negative 1 less than or equal to x, less than or equal to 1. So again, talking about this one, again, when we did our cosine graph, we'd have to limit it. We can't go negative pi halves to pi halves because that fails. And so this time we had to go from 0 to pi. And ignore the rest, because it has to pass the horizontal line test. Okay, and now we're going to talk about the tangent function. So remember, that would be y over x. And one thing is, because it's tangent, we have so many vertical asymptotes. And so because of that, we use less than instead of less than or equal to. So I know I put the symbol here, but I wanted you to emphasize it. It's less than instead of less than or equal to. All these others were less than or equal to, but here it's less than. And then for C, if we have y equal tan negative 1x, that's the same as x equal tan y. And this time we're going from negative infinity to infinity, but then negative pi halves to pi halves like we were for sine. So then this one would look like tan negative 1 of tan of x. And again, we're using negative pi halves to pi halves when the f negative 1 is on the outside. But the other one, we're going tan of tan negative 1 of x, and that would go from negative infinity to infinity. So like the graph that I have on here, the red one is the inverse tangent, so that domain is negative infinity to infinity. Okay, so now let's start with the problems. Let's write those down. Okay, so here's your problem numbers again. To start with, we're going to do number 7. And it says y equal sine negative 1 of x means And this is where we do what we did in the notes earlier, and we just say x equal sine y. So I'll just write this one extra time. To get rid of the sine -1, we do sine to both sides. And then those cancel, so you get sine y equal x. But this is the part that you need.
So you're really just switching them.
Yeah, we're basically switching from y to x, and from sine -1 to sine, and from x to y. Yeah. Okay, good. Number 8, we're going cosine -1 of cosine. And we need to know the interval for that. So again, I did this a little bit on the other paper. We need to restrict it from 0 to pi.
Wait, why do we have to restrict them?
Because we have to pass the vertical and the horizontal line test. The vertical would have been passed throughout, but see, that part would fail because there's a left and a right side, and so we have to ignore this side, and so we have to just use 0 to pi for it to pass the horizontal line test. And so that means we need 0 less than or equal to x less than or equal to pi, or you could just put 0 pi. So,
And you want to pass the horizontal?
yes, we do. Yeah, exactly right. So that part you have to write. If you don't want to draw the graph, you don't have to. Okay, number 9. This time we're going to do tan of tan -1 of x, and it's equal to x. So notice the inverse is on the inside on this one. So your regular tangent graph looks like this, which was basically -pi-halves to pi-halves. And when we do our inverse, it's going to look like that, where it's tilted, and it's going to go from -pi to pi. So this is going to be, oh, I meant -infinity to infinity. Sorry, -infinity to infinity. So we want -infinity less than x less than infinity, or you could use your parentheses like that. Okay, then number 10 is a true-false question, and it's saying the domain of sine -1 is -pi-halves to pi-halves. So this would actually be a tricky question to me, because I know that's one of our valid intervals for sine, but this would be false because it's -1 to 1. For sine -1, the domain is, well, -1 to 1. And the range is -pi-halves to pi-halves. So they basically want that it's false because they're trying to confuse you. They're putting domain, and it should be range for it to be true. Okay, so that's number 10. Any questions? Yeah, we get out at 10:25 today. Okay, so next we have number 11. And it's a true-false question that says sine of sine -1, 0 equals 0, and cosine -1 of 0 equals 0. So what we want to do is just go to our regular calculator screen and do both. So if we do sine of sine -1 of 0, sure enough we get 0. And if we do cosine of cosine -1 of 0, we also get 0. So this is going to be true, checked with the calculator. Okay, number 12. This one we have a true-false question. Y equal tan -1 of x means x equal tan y. So we switched y to x and inverse to regular and x to y. So that, yes, that's going to be true. Okay, so that's a good question. We've got y equal tan -1 of x. So if you have a tan -1 here, that means to get rid of it and to isolate x, you've got to do tan to both sides. So you go tan y equal tan of tan -1 of x. And then those cancel, so then you get tan y equal x. It's kind of like the same as if you did +3 to this side, then you've got to do +3 to this side. So if we do tan to this side, then we have to do tan to that side. So it's the same idea. Okay, I'm going to call that a good stopping point because the next ones we're going to do on the calculator